Morning, everybody. Here we are on another great weekend. I hope you weren't too afraid because of the big old protest in Washington, D.C. I was a little bit afraid, I guess. But anyway, today we have another video of Mark Sargent. Good old Mark Sargent. He is a fascinating source of false information. I really think sometimes he knows it's false. He knows he's lying. So let's see just how interesting this last video is. You're going to really enjoy question number 5, although he doesn't mention the number on this one. But it's question number 5. And right before I start, let me tell you, you need to stay till the end. There's a really interesting surprise for you at the end. I dug this up just for you guys. So please stay all the way to the end. So here we go. Let's listen to Mark Sargent as he explains to us about the lunar lander.
The Van Allen belts. A simple yes or no question. Are the Van Allen radiation belts deadly? If yes, then how did Apollo 11 through 17 make round trips through these belts with only aluminum and plastic as shielding? No one died, no one got radiation poisoning, nobody even got cancer. I think there's still like 5 left. Radiation is only stopped by 2 metals, lead and gold. Both are very heavy and cannot be used in aerospace because of their weight. If the answer is no, the belts are not deadly, then explain the video currently on the NASA.gov website called Orion Trial by Fire, in which NASA clearly states the belts are so dangerous they will not be testing manned capsules because they are unable to solve the radiation problem. Keep in mind, this is not an old video. It was created at the end of 2014. The scientist viewed my recording and folded like a card table. This piece was never aired. All that being said, my name is Mark Kendall Sargent, and I'm a flat earther.
Okay, well, thank you, Mark. I know that Mark and a lot of these flat earthers were actually moon landing conspirators. They just don't believe that we ever went to the moon. Now I know his first point was going through the Van Allen belts. But before we get to that, let me talk a little bit about what exactly they took to the moon. So everything is in a rocket, an Apollo rocket, just like the regular rockets that you see taking off. The lunar lander is called a LEM, LEM, which stands for Lunar Expedition Module, LEM. That part was never made to go through the atmosphere by itself. So if it took off from the ground by itself, it wouldn't make it very far. So the LEM was inside the rocket as part of its payload. And so as the rocket took off, that's what happened. The other part that he mentions is the rover that they used on the moon. And he said, well, how could they get that rover on that small limb? And the thing is, they didn't put it on the limb. In the rocket, there was a lot of empty room there, and the scientists or engineers decided, hey, there's enough room that we could put this lunar rover in there. And so they did that. So the Apollo rocket that took off was what went through the Van Allen belt. And the first thing that you'll find if you check Google and look at it, you'll see that the path of the Apollo rocket was through the polar regions. At the polar regions, there's very little Van Allen belts of the radiation. At the pole, there is no radiation from the Van Allen belts. And so they planned their path through that lower part and out into space. You've got to realize that lunar lander that they used, or not the lunar lander, but the rocket that they used was built to withstand some of that radiation. And so the rocket itself had a lot of the electronics, the computer, and the water tanks, the water storage around the outside of the rocket, so that there was a barrier for the radiation. And that barrier helped to keep the radiation out, so that inside, they say, there was about the equivalent of one CT scan on the inside of the rocket. Now, let's see. So once they got through the Van Allen belts, the radiation was not there. Also, the one thing I wanted to mention was that each astronaut carried a radiation counter on his body. It looks like a pin, sort of a big pin that they carried. And there was also a radiation counter in the cabin there, so that they could check to see what kind of radiation that the astronauts went through. And when they got back, it turned out that all of those radiation counters were close to zero. So, they're all worried about this radiation, which really wasn't that big of a deal. Okay, so once we get through the Van Allen belts, we go to the moon, and the lunar lander itself was deployed so they could land, and they landed on the moon. You have to realize that the gravity is different on the moon, and there is no atmosphere. So the response to landing on the moon, to the dust or whatever is going to be totally different than what you see on the Earth. So you might think that, how come they didn't stir up a dust cloud? Well, there was no atmosphere. Why didn't they make impressions in the dust? Again, the gravity was much less. There is no atmosphere. All of those things go into account. Another thing I saw, this isn't in his presentation, but another thing I saw is them making fun of astronauts that were falling down and jumping and making silly moves. And once again, you have to realize that the gravity is different on the moon. So when they jump, they're going to float down differently. Their walking is going to be different. The way that the lunar rover moves is going to be different. So all these things are going to need to be taken into account when you talk about going to the moon. All of these are different than what we'd expect on Earth. And so, the lunar lander, when it takes off, it needs less fuel to take off because the moon has less gravity. When it gets to space, it docks with a rocket that's been circling the moon. One of the astronauts got to stay up there. He missed walking on the moon. And so once they dock, they leave. Part of the lunar lander is left on the moon. The other part docks with the rocket and is outside the rocket. When they come back, once again, they go through the Van Allen belts as minimum as possible. Their path, they can control that. So their path goes through the minimum part, and they don't have to worry so much about the Van Allen belts. Once again, I said they had very little radiation. One of the other things I didn't mention is that the rocket itself was made of much thicker metal. So that thick metal also protected from the radiation. The radiation in the Van Allen belts is a totally different kind of radiation than is found, like in uranium or whatever like that. So whatever radiation they run into is totally different than the radiation of what we go through on Earth. So as the rocket descends, the lunar lander is ejected and burns up in the atmosphere. So that's the reason why it, is made of those light materials. Looks like it's going to fall apart. So that's the purpose for that. So then when you go back to the landing, it's in that capsule that you see. It's not in the lunar lander. It's a different part of the rocket, and you can see that when they land. Okay? And so that's my take on the lunar landing, the Van Allen belts, and so forth. So there's a video that I want you to watch right now. It's a really funny video that Mark Sargent prepared. You just can't imagine I don't even know what to call it, the idiocy of making this video. He is in a debate with a PhD astrophysicist, and he makes this statement to the astrophysicist as part of their debate. So I think you'll really like it and get a good laugh. So here that comes.
What's interesting, though, is, and this would be more or less a representation of the flat Earth, a self-contained system roughly the same size. But here's the big difference. This can't exist on its own. It uses a huge support system to survive, meaning you need a sun and a solar system and a galaxy and a universe around it, where this needs nothing. This is just, if you look inside it, there's your world. So the question is, why couldn't that be possible?